product of AK through AL, what we are going to do is we are going to split that into AK through AI and then AI plus 1 through AL, right? So I'm going to compute the product of this sequence of matrices in the optimal way. Then I'm going to compute the product of this sequence of matrices in the optimal way, and then I'm going to simply multiply the resulting two matrices, right? And I'm going to then try doing this for every possible value of I from k plus 1 through, L minus 1, right? So I'm going to try every possible value, and that is this min operation. So I'm going to let I go from anywhere from k to L, okay? And then I'm going to find the best way to compute the first group there, and then I'm going to pick up the best way to do the second group. So I'm going to combine the cost of those with the cost of doing the outer multiplication at that level, okay? And that is what this formula says. And once I pick the minimum, well, then I'm done, right? So then I've considered every possible way of computing this matrix multiplication and found out whichever is going to be the minimum. Okay, so then that's how I do chain matrix multiplication. So once again, is there a question?
Can you do a diagram with the example that you showed ABCD?
Okay, so what have you done here with ABCD, right? So see, sometimes the examples actually don't help. That's why I don't go through the example, because the examples is an ABCD and it's not, A1, A2, A3, A4, right? So what we are considering is, if you fill out the table, right? So we have A1, A2, A3, A4, right? So the first time we go through the loop, what we are going to do is we are going to pick strings of length, sequence of, actually the algorithm will try to pick sequence of length 1 or something like that, because for the algorithm it doesn't matter. For us, we want to minimize every operation that we do. So what the algorithm will consider is, it will consider multiplying these two, then these two, and these two. Okay? And so that will, you can make those computations. A times B is going to be what? 5,000, right? No, 1,000, right? So this is 1,000. And A2 times A3 is 200, right? And A3 times A4 is, what is it, 100? 1,000, right? So that's 1,000, right? So this is the first iteration of the outer loop would have computed these three, okay? Then in the next iteration, you're going to consider sequences of 3, right? So sequences of 3, you could either pick these two, right? Or you can pick these two, right? So this is A1 times A2 is a 50 by 1 matrix, right? So this is a 50 by 1 matrix, and this one is 20 by 10 matrix, right? And the third one is 1 by 100 matrix. Yeah, just tell me if I'm making a mistake, right? Because obviously I'm trying to read the. And now you consider doing this product. Well, that gives you 50 times 20 times 10, which is 10,000, right? Okay. And this gives you 20 times 10 times 100, which is 2,100. No, 200 times 100, which is 20k, right? Okay, so now I come to the last point, which is to look at everything, right? Now to look at everything, I have 3 choices to consider, right? So I can take A1 times A2 and A3 times A4, right? So for figuring out how to do the 4-way multiplication, right? So I need to pick a dividing point, right? So the dividing point I might pick is over here, right? So if I pick this, right, then the way the total cost of multiplication is that of multiplying A1 with A2, A3, A4, right? So A2, A3, A4 is, did I even compute that? I guess I haven't. Yeah, I haven't computed everything that I need, right? Because I have only computed, yeah, so so you can see that what I have not computed is the cost of multiplying A2 times A3 with A4, right? I haven't really multiplied it. So let's so let us do this. See, this is why I don't work out the example, because there are actually so many combinations in dynamic programming algorithms. So trying to work out on board just takes forever, right? So so this is 50 by, or did I erase everything? Okay, so let's do A1 times A2 is 1,000, right?
1,200 and
1,200 and 1,000, right? So now what I need to do is I need to do 3 things which I didn't do carefully, and that is, considering 3 means I need to consider 2 of these and then A3, right? So instead I did something else, right, which made no sense, and you should have told me that it made no sense. Okay, so now we have to consider these 3, and that is going to be so 50 times 1 matrix, right, is being combined with A3, which is 1 times 10, right? So let me write this down here so we know what the yeah.
the first one is 50 by 20.
Okay, so now if you combine, then you see a 50 times 1 matrix being combined with 1 times 100. So if I pick those 3, right, then I will have a cost of 50 times 1 times 10, 5,000, right? And 500? Okay. 50 times
1 times 10.
50 times 1 times 500, okay, right? And then if I pick these 3, then to get to these 3, what I'm doing is I'm picking this multiplication of again, I'm sorry, so see, this is why it doesn't work, right? Because I have to consider not just this combination, but I also have to consider the way of combining A1, A2, and A3 first, right? So let's just go through this in a systematic way, right? So if I want to compute for A1, A2, A3, right, I have to again pick a partition point, right? So I need to pick 1 or 2, right? So if I pick 1, then I'm going to multiply A1 with these 2, right? So these 2 I already have computed, and by considering that combination, I'm going to arrive at some number, right? Same way, the other possibility is I first multiply these 2 and then multiply by A3, which means the partitioning point is over here. So I have to consider that partitioning point and then compute that, right? So, and once I do that, I do the same thing for A2, A3, A4. I pick this partition point, okay, and then compute the minimum, and then I compute this partition point, and now I have for all sequences of 3, I have the answer. Then I use that information to compute for all 4, right? And you can go home and do this, work it out by hand. So again, the important thing is to understand it is much easier to understand the idea that the way you multiply a sequence of things is you pick some point that corresponds to the last multiplication, and then you do the thing recursively for both sides, right? So this is what we should be able to understand after spending several weeks on recursion. Okay, so the complexity of this algorithm is n cube, which you can fairly easily see. We have 2 nested loops, right? Each of them going through n times, so that already gives you n squared. And inside the nested loop is a min operation, which goes through k to l, right? And you can see that the difference between k to l is given by the value of s, which means that it is going to be on the average n by 2, right? Because s goes from 1 to n, so the average value of s will be n by 2, which means that this min operation is going to execute about n by 2 times each time you execute this, which means that you have n cube algorithm.